So now that we have looked at position graphs, we're going to move on to velocity graphs, okay? Even though they're both about motion and they can show the same thing, they are showing different aspects of the same motion. Okay, so you've got to separate that. That's step number one, is to realize we're looking at a velocity graph. It sounds simple, but once you start looking at lines, you tend to equate it with a position graph, and that is not true. As always, step one is always figuring out what are we looking at? What are we starting out at? So the initial velocity is going to be one of three things. Number one, it can be a positive velocity, okay? A positive velocity is going to be anywhere above the x-axis, okay? So it could start here, start up here, start here. Doesn't matter. Positive velocity is above the x-axis. And what that means that your object is moving forward or up, depending on which way we're looking at. We're saying moving forward, okay? No, it says it is moving forward. It does not say, excuse me, it does not say we start ahead of zero. It does not say anything about where we start our position. It says that at that initial point, we are moving forward. Okay? The second option we have is you can start off with zero velocity, which means you are stationary. Zero velocity obviously is going to be our point at 0, 0. It means we're not moving at all. Okay? Again, it doesn't necessarily talk about where we're starting. It just means you are starting at rest. Okay? You might start moving right away, or you might stay still for a bit. That depends on what happens next. Okay? Then our third option, logically, would be our negative velocity. Okay? So that's going to be somewhere below the x-axis. So anywhere down here, negative velocity, negative velocity, negative velocity. Anything below that x-axis means you are moving backwards, okay? And so the farther negative you are, the faster you're moving backwards, but nonetheless, you're still moving backwards. Now, once you've established whether or not you're moving and whether you're moving forward or backwards if you are, you've got to look at what happens to that velocity, right? So again, we're going to have two options. It can either stay constant, and if velocity is constant on the velocity graph, means it is a horizontal line. Horizontal because constant means it's not changing. If it's not changing, it's going to stay at the same velocity. For example, my initial velocity is here, and then I've got a line going out to the side. This. That means is for 4 seconds, I am moving at that same exact velocity. Okay, that is not unlike the position graph that says you're staying still because the position's not changing. Here, our velocity is not changing. So our position will still be changing as a result of constant velocity. Okay? Or, again, we're going to have changing velocity, which means accelerating. So our two options are positive acceleration, meaning the line is going to go upwards with a positive slope. Okay? That is because our acceleration is our change in velocity per time. Change in velocity per time on a velocity graph is our slope. Okay? And so no matter where it starts, if it's sloping upward, no matter what, all three of those have a positive acceleration. Okay? But again, you're going to look at this first one, top one here, starts moving forward and then moves forward faster. This middle one starts at rest, so starts not moving, and then increases its velocity going forward. And this third one we see here, it starts out below the x-axis, increases its velocity until right here where it actually stops. So it moves backward this entire time because your velocity is negative, but it is actually slowing down because it starts moving backwards at a negative velocity, let's say negative 2 meters per second here, and then it ends up stopping. Okay? And obviously our other option is going to be negative acceleration, which means our velocity is decreasing. Excuse me. So it is going to have a negative slope. Okay? Just like with positive acceleration, it does not matter where it starts. Okay? For that line, you start at zero velocity, so we're not moving, and then you start to move backwards, and you move backwards at a faster and faster rate, you're negatively accelerating. Okay? If you start up here and you come down to here, you start moving forward, and then you slow down, slow down, slow down until you stop moving. Okay? So let's take a couple looks at some examples to see what this is going to look like. Okay? So here we have a velocity graph. Okay. Step one is how are we moving? Okay. Initial velocity, okay, either VI or V naught, same thing. Initial velocity is 4 meters per second. Okay? So I am moving forward at time 0. You start out moving forward at 4 meters per second. Okay? Then we note, let's see here, this line is a horizontal line. Okay? So we know now at the first 2 seconds, the velocity is constant. And as it started at 4 meters per second and stays there, your velocity is a constant 4 meters per second. Okay. I am moving forward at 4 meters per second that entire time. Okay. Our third section here, we see that it has a slope, okay, which means it's no longer constant velocity, it is changing. The slope here is negative, which means my acceleration is negative. Because my velocity is positive and my acceleration is negative, that means I am also slowing down. So from 2 seconds to 3 seconds, arrow, you are still moving forward. Even though your line is sloping downwards, all of those velocities are positive, right? You got positive velocities, so you're still moving forward, but because your velocity is decreasing here, you end up stopping right here, okay? So you're moving forward because all of those velocities are positive, but you're slowing down and stop. Okay. Being at 4 meters per second to 0 meters per second shows you're slowing down. In this case, velocity decreases as does your speed. Okay, and then this last section, okay, there's a line there. It's a horizontal line, so again, it's going to be constant velocity, but it's at 0 velocity. So that means from 3 seconds to 5 seconds, it doesn't move. Okay? It is absolutely stationary because you have 0 velocity. Okay. Let's take a look at one more. Okay, it's going to be a little different than that one, but still, you follow the same steps every single time. Number 1, you have to look at where is your initial velocity. Negative 2 meters per second is your initial velocity. Because it's negative, you start out moving backwards. When you do this step, don't look at the line. Look at where it is on that y-axis, and that tells you what direction you're moving. Then you're going to look at what happens next. Because the x-axis is here, okay, it crosses that. We're going to treat each section below and above the x-axis as separate sections. So here we have velocity is increasing, but speed is actually going to be decreasing. Okay, velocity is increasing, so we've got positive acceleration. Slowing down though, why is that? It's because speed is an absolute value of velocity. So the absolute value of negative 2 meters per second going to 0 meters per second is a decrease, right? Oops. That. Decrease in speed, but it's an increase in velocity because 0 is actually greater than negative 2. Okay. Then that third section is up here. It is still positive acceleration, but now we've got a positive velocity, so we are moving forward. You'll note that in between these two sections, it crosses that x-axis here. Okay. Okay, this is technically going to be here in the order, but I just want to point this out to be specific. It crosses the x-axis, so our velocity there is 0 meters per second. Okay, you start out going backwards, you slow down and stop, then go forward, right? You're increasing velocity, so you are then speeding up here. Oops, sorry guys. In order to change directions, you have to stop momentarily. Okay? Follow this process on any velocity graph you have. Okay? Good luck.